Okay. Yes, Suvi, you can lead us in a word of prayer.
Okay. Let's also Heavenly Father, for today, thank you for we are going to have our lesson. Dear Lord, we thank you for the platform I pray that you speak each one of us. May you guide our teacher, our teacher, and that we must pray that may you maybe now when there is nothing else to pray for this.
Okay. Okay. Thank you, Suvi, for the word of prayer, and happy New Year to everyone that is on the call. Thank you so much for joining. Today we are starting on our senior 4 work. So anything we are going to do today, it is senior 4 work strictly.
Recording in progress.
So it is senior 4. Okay. Yes. So that's what we are going to do today. So anything we are doing is something very new. I know some of you have not yet covered, but it's going to be of great importance. We are going to start with an activity. And when you check on my screen, I'm displaying different things. So I'm going to have a question posed, and then I'll ask you to identify all the items in the picture. So I want you to just type in the chat what you are able to see on your screen, or what is appearing on your screen, anything you know. Yes, just type it in the chat that this, and the rest. Okay, good. So in the chat, I'm seeing people are putting sugar cane, they are putting juice, medicine, tabs, juice. Yes, okay. That is very true. Thank you. I have another question. Is there a relation that exists between the items named from the picture? What relation exists, and explain your response? Feel free to raise up your hand for this particular question, and then you can share with us. Okay. Yes, Favor?
Good afternoon, everyone. For the juice, we see that it is a product from the sugar cane. So the sugar cane are raw materials which are used for making the juice.
Yeah, perfect. Thank you, Favor. Yes, Desire?
And for the sweets, we all know that something sweet, of course, it originates from sugar. So firstly, it comes from the sugar cane. From the sugar cane, it goes under industrial processes and it becomes sugar. Then from that, that sugar is also used in the making of the lollipop, which is the sweet.
Okay, perfect. Thank you so much. Jessica?
Okay, what I'm seeing is sugar cane and the products got from sugar cane, like sugar, the lollipop, and the medicine. Yeah.
Okay, thank you so much. That is perfect. Let me hope everyone in the chat or everyone has been able to note that kind of relation they have been able to share with us. I have another question. Okay, you can raise up your Yes, Carol, go on.
I did.
Okay. Jessica, come on.
Okay, there is this picture of this lollipop and medicine cause they used sugar that is processed from the sugar cane to make the lollipop and the medicine. Yeah, that's all.
Okay, thank you so much. That is correct. Agatha?
Okay, according to me, I think when it comes to the part of the medicine, when you overconsume the sweets that are manufactured from the sugar, you end up getting diabetes and you're required to take in the medicine.
Okay, thank you, Agatha. Yes, Tekino? 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 Oh, I'm failing to get Tekino. Desire?
Okay, it's the lollipop because for it to become like that, remember it first started from the lollipop because it will first like they will add some other ingredients or some other preservatives and many other things to make it taste like that. So it's the one I would say it went under multiple change in order to become what it is.
Okay. Perfect. Then the last one, J404. You are the last one. J404, unmute.
Okay, so I just want to talk about the lollipops.
Yes.
So I just wanted to say that the lollipops actually came from the sugar, which was hard boiled, and dye was added, plus flavoring to form the sweet.
Wow, wow. Okay, perfect. Thank you. Now, all what you have been sharing is what we are going to be looking at in this particular topic that we are starting. You have noticed that the products we have been having, they have gone through multiple processes. And it is through this multiple process that in order for us to get one, it means that you used the first one to act as the input. In order for us to be able to get sugar, it means that you needed to have sugar canes. And then for you to get the sweets, or what you are calling, I think you call them lollipop. In order for us to get them, you must have had sugar. So you are noticing that in order for us to get one product, you need another product. So you are noticing that to get sugar, you needed to use sugarcane. So sugarcane is what we call an input. In order for you to get sweets, you needed to get sugar. So sugar is an input for the sweets. So this topic that we are going to be dealing with, it is a topic that involves multiple change process. And mathematically, those inputs are what we are going to be calling the functions. That sugarcane to sugar, this is going to be one function. And like for this particular, we can say, maybe we can call it S as our function. For us to get sweets, we are going to need another function. So here we shall perform another task. So there is a process. Now that kind of process that takes place for us to move from sugarcane to sugar is what we shall be calling the function. So that function, we are going to be performing a given task in order for us to be able to get that particular product. So this is what is going to be contained within this particular topic. And now you have noticed that for us to get the medicine, on that medicine, they make some kind of coating on it. So that coating, in order for them to make the coating, they will need the sugar. But in order for us to have the sugar, you will need the sugar canes. So you can note that there is a step-by-step kind of process in order for us to be able to get a product for the other product or for the other output. So that is what we are going to be doing in this particular topic. So you are going to be getting one. Let me say you'll be, in order for you to get sugar, you'll have to use the sugar cane. In order for you to get the medicine, we shall need to have the sugar. So we shall be performing what you call multiple processes in order for us to be able to get the output. So one output feeds the other. One output feeds the other. So you keep on feeding the other, you keep on feeding the other in order for you to be able to get. But how are they going to be appearing mathematically? Now, mathematically, we are going to be calling them functions. So you're going to be performing a function or what you call a task or a process. Let me say mathematically, here you can call it F. Then here you can call it, let me say G. So you are going to be performing these two tasks F and G. But that one, we are going to dive deep into it. But in other words, the whole of this topic, we are looking at multiple change processes. Okay, and now the topic we are going to look at is called composite functions. So let me ask you now to write your topic, composite functions. Composite functions. Now, I want you to, in this topic, we have some keywords that we are going to be meeting. So I want you to look at the table you have there and check whether you can be able to identify any of these words. Just check through the table and see whether you can be able to identify any word quickly. I don't know whether I can allow you to annotate. Yes, let me allow you to annotate on my screen. Yes, you can write on my screen, but I want you to circle where you are seeing those different words. Okay. Okay, good. Yes, I've seen one person has been able to get notation. Mara, I don't know which word you're trying. Uh, Okay, function has been identified. Okay, inverse. Yeah, so you write those words as your keywords. So write them as your keywords. I've seen Melissa, I've seen Priscilla, Arnold. Okay, now write those words as your keywords. Write them as your keywords. Write them as your keywords. Okay. Yeah, allow me to clean my screen. Yeah, so you write those are some of the keywords that we are going to be interacting with in this topic. You are going to meet a word inverse, mapping, domain, range. You'll meet composite, graphical, quotable annotation. So those are some of the words that we are going to be meeting in this topic. So write them as your keywords. Allow me to show them to you here. So that's how those words, you were supposed to get them. Okay, I think, okay, it is okay now. I think I've been able to disable. Okay. Yeah, so you write those as your keywords. Write them as your keywords. And I'm sure in senior 2, you were able to interact with some. Yes, Zoom, you have a question?
What subject is this?
This is math.
Okay.
Okay. Okay. I think we have finished. I think I can use, okay, people have finished. Okay. Now I'm going to look at the key learning outcomes, what you are supposed to know by the end of this lesson. One is going to be able to understand and use function notations. And then the second one, though we shall not go deeper into the composite function, but today our major focus is going to be being able to use function notation. That's where we are going to concentrate. But before we dig deep, we need to know what we call a notation or what we call a function. Now, mathematically, when we are talking about function notation, mathematically, I want to draw your attention to the equations you have been meeting in math. You have been dealing with equations and the rest. You have been meeting things like y is equal to 2x plus 1. Now, your y is always what you call the function. And then the x's is what you call the input. So input, so we have two words I'm going to be using. What we call the input and what we call the output. So the output is your y. The input is your x. So take an example. When I take you back to the sugar cane and then the sugar. So sugar, I want you to tell me in the chat, on sugarcane, what is your input and what is the output? Yes. You can just type in the chat quickly. Which one will you take as your input and which one will you take as your output? I have sugarcane and sugar. Very good, Davinia. Yes, sugar is the output. That is good, Faith. Yes. Then the input is the sugarcane. Yes. Now, for this particular case, your y here is going to be the sugarcane. Your sugarcane is going to be the x. And then the sugar, what you get as your output is what you call the y. So your function here, mathematically, when we come to functions, we shall represent our function by letters such as f. And what you put inside is what you call the input. So when I put here x, it means that f is the function, x is the input. So take an example. For sugar, I will put this is sugar. For us to get sugar, I will say, for us to be able to get sugar, we shall put the sugar canes. So that's how we write it. So capital S is standing for sugar, and inside it, for us to be able to get that sugar, we shall put the sugar canes. So that's what we call when it comes to a function. So whenever you find a function written like g of x, we read it as g of x. So what you see here, x, is always your input. What you see as g is going to be your output. So the common letters you are going to be finding is going to be f, is going to be x, is going to be, we mainly use f and g. Sometimes we can use h, sometimes we can use, but those are the common letters that you are going to be finding in this particular topic. So those letters are going to be very common. And we shall always read it as f of x, and it means the function. So I want you now to use this screen, summarize about what you call function notation. So we read it as f of x. So may I ask you to summarize? Okay, it seems people have finished. Yes, people have finished. Okay, we are good to start. Marion, you had a question, but you are not unmuting. You are not unmuting. So I think I'm going to just continue. Okay, we are going to have an activity. Now, when you look at my screen, on my screen, I have in. So in is the input. Then this is our out is the output. Now, we are asked to find out the output. Can we fill in this table in the chart? This is A, allow me to call this part B, allow me to call this C, and this one D. They're telling you, when you put in your machine and you add it to, what do you get as your output? So quickly through the chart, can you fill in what you have here? Yes, we are using the chart quickly. Okay. Those who are just joining in, we are filling in that table. We are filling in that table. Okay. I think many of you have been able to, okay. Okay, I'm seeing the answers. I'm seeing the answers. Okay, good. Yeah. Now, when we put 4 inside here, our machine, the 4 will come in here. And now they're telling us add the 2. So I'll say 4 plus 2, and our answer here, we shall obtain our answer as 6. So here we shall have 6. When we bring in here and we put a 3, we shall add on a 2. So 3 plus 2, we shall get our answer as 5. So here we shall end up with 5. When we put in 0, I'll have 0 plus that 2, and then I'll get my answers as 2. So here we are going to have our answers 2. Then the last one is 5. So when we bring in 5 plus 2, we shall get that answer as 7. Now, that is how our machines work. And that's how we are going to be going through the different process. So here it's like when you put sugar in the when you put sugar canes in the machine, you'll be able to process the sugar. So, but this one is a one process. Put sugar cane, you'll get the juice. Or you put this, you get this. So that's what we are going to do when it into these machines. Hope, are we on the same page, members? Kindly let me know through the chat. Are we on the same page? Are we on the same page? Okay, yeah, yes. Okay, it seems we're on the same page. Okay, we are going to now continue. Okay, we have the second activity. Now, when you look at this activity, we have our function. Like I told you earlier on that our functions, we can use different letters. You can find this letter H as F. You can find another time when they have used the key. You can find another time when they have used maybe P. So it can be any letter. And we say that H is always our output and X is the input. So the first one, I may do for you one, and then you try for me the rest. So they are telling us that what happens when this is the function the machine is going to process. What happens when we put -4? What does it mean? When I have h of x, it means that in this function, wherever I'm seeing x, I'm going to put -4. So wherever you see x, you put -4. So I'm going to come and I say, my h of x will equal to 6x plus 2. But our function, they want us to input -4. So I'll come and I say, this is h of -4. Therefore, where I'm seeing x, wherever x appears is where you're going to put your -4. So I'll come and I say 6 times -4. It is always, whenever you meet a negative, always it is a good practice, you can put a bracket. Then you'll come and ask 6 times -4, what do I get? That is -24, then plus 2. Then you say -24 plus 2, what do I obtain? That I'm going to obtain -22. So it means that whenever you put in a -4, you'll obtain a -22 for this particular function. Let me hope we are together on that. You can let me know through the chat whether we're okay. In fact, people have already got the answer. Are we together, everyone, or there are people who may need our pardon? Okay, some are saying yes, yeah. Okay. May I, we are together. Okay. Can we now okay. Can we now try out part B, part C, and then lastly part D? Everyone, try out on your own. Check. So you are going to come here where there is X for you put 0. So can we try out? Let me give you 4 minutes and then we can start. Okay, those who are just coming in, we are trying out part B, C, and D. So can we have people raise their hands and then they take us through part B, part C, and then part D? You just raise up, okay? We shall start with Maria Deborah. Yes, Deborah? I'm failing to get Deborah. Mark? Should I have Mark? Oh, sorry, search Mark.
I'm going to take you through part B. Part B, we are having h of 0. So that means that I'm going to replace the x with 0. So if you multiply 6 times 0, it's an obvious 0, right? Then plus 2, where the answer becomes 2 at the end of that day.
Okay, thank you, Mark. That is true. Yes. Okay, so 6 times 0, yes, so that is 0 plus 2 will equal to 2. Okay, that is correct. Thank you, Mark. Yes, Maria?
We are going to I'm going to work upon part C, and we are going to replace x with 1. So it will be 6 times x, 6 times 1 plus 2, which is 6 plus 2. And at the end, we shall have 8.
Okay, thank you. That is correct. Thank you, Maria. Then,
You're welcome, sir.
okay. Reflection, something like that. Unmute. Your background is bad. Lily?
So basically, I'm going to take you through part D. So it is h of replace. I'm going to replace the x with 3. So it is 6 times 3 plus 2, which is 6 times 3 is going to be 18. Then plus 2, and you later on get 20, because 18 plus 2 is 20.
Okay. Thank you. Okay, those
Okay.
are our answers. Let me hope everyone has those answers. Okay, is that fine, members? Okay, hope we are good to continue. Yes, so we are going to continue. Allow me to remove them. Okay, I have another activity. Evaluate the function. Can we quickly do it? And you place your answer in the chat. Okay. Yes. Joyce, can you take us through what you are getting?
So I first write down the equation. F to x is equal to 2x plus 1 and x is equal to 3.
Okay.
So f into 3 is equal to 2 times 3 plus 1. So it's 6 plus 1. F to 3 is equal to 7.
Thank you. Okay, let me hope everyone has those answers. Okay, so those are the answer. That is the answer I expect you to have. Okay, now we have gone to another one. Now we are going to apply. Many of these topics you cover, they may require you to use the previous knowledge. So in third term, I know you looked at what you called quadratic equations. So this topic here, at some point you'll find yourself needing to use that knowledge of quadratic equations. So can we first give it a try? Yes, I'm interested in part A. Can we everyone first try out part A? Looking at your understanding, I want you to use your knowledge, what you have understood from the topic so far, to see whether we can do part A. Can we first try it? Let me give you some 3 minutes. I'm going to look through the chat. When you get part B, Jonathan is saying 9, others are getting 5, and someone is saying I'm lost. Okay. Yeah, we are trying. Virginia is getting 5. I'm not getting it. Lost. 4, 2, lost. Okay. I get it. Okay. Okay, I'm going to slow down. Okay. Okay. Looking through the chat, the majority, I think they're a bit lost, but I'm seeing Mark has his hand up. Yes, Mark.
I got B as 5. I
Okay.
replaced I I I replaced okay, I don't know how to explain it, but I did it as 18 is equal to bx squared minus 2, and then the x, put it as 2. Then I was having 18 is equal to b 2 squared minus 2. So 2 squared, that is obviously 4. So it's like I'm having 4b minus 2. Then obviously the 2 went the other side as a plus, then it became 18 plus 2, whereby I was having 20 is equal to 4b. And when I divided, I got 5, though I'm not sure if what I did was right.
Okay, thank you. That is okay, Mark. Yes, Virginia?
Teacher, I had the same explanation as him. Basically, the f in brackets x is equal to bx squared minus 2, and f into brackets 2 is equal to 18. So I made them relate in a way. I converted the x on the other side. I replaced the x with 2, and I equated the bx squared minus 2 to 18. So I converted, so I got B, 2 squared minus 2 is equal to 18. Then I got then I got 4B minus 2 plus 2 is equal to 18 plus 2. And then I got 4B is equal to 18. Is equal to 20. Then I divided on both sides and got 5. I got the same answer as Mark.
Okay, thank you. Thank you. I think those people are on track. Okay, we can do it now together. Now, what happens? We have f of 2 is equal to 18. Now, this one simply tells you that when you, in this function, they have told you that your function, what they want you to perform is this. They are telling you that our input is the 2, this input. But they are telling you that when you put 2 inside this function, the answer you're going to get is 18. They have given you what you're going to get. Or they are in simple terms, they're saying that when you put something inside this machine, what you are getting out is 18. But now their question is, what value is this B? What was the value of B? Such that when you put your value, when you put your 2 inside, you get your answers 18. So that's what they don't have. They don't know which unknown is this B. That's what now we need to find out. So what does it mean? It means that what we are going to do, our function, our output already is known as 18. But we need to find out what is this value of B. So I'm going to come and write my function f of x is equal to bx squared minus 2. But our input is 2. So I'm going to come and I say f of 2 is equal to b, then times where there is x is where we are putting the 2. So I'll say 2 squared, then minus 2. So you need to remember that when they say 2 squared means 2 times 2, which will give us a 4. So here we shall have our b times the 4 minus 2. So when I have b times 4, I'll end up with 4b minus 2, and this is our f of 2. But they have told us that the moment you put 2 into your function, the answer as you will get is going to be 18. So it means that where we have f of 2, I'm going to put there 18. Or the whole of this function here is going to be equaling to 18. So I'm going to say now 4b minus 2 will equal to 18. Now, the moment I reach at this step, I'm going to go on and I collect like terms. So when I'm collecting, this 2 is going to cross over this side. And since it is a negative, the moment it crosses, it becomes a positive. So I'll say 4b minus 2 plus 2 will equal to 18 plus 2. So here I'll end up with 4b is equal to 18 plus 2, which will give us a 20. So in order for me to obtain that constant value, I'll divide this side by 4, divide by 4, and I'll end up getting the value of b as my 5. So that's how they have been able to get it. Let me hope, kindly let me know through the chat whether we have understood that. Kindly just say yes, 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 and then we see. Yeah. Oh, okay, very good. Now, if that is okay, now what we are going to do, can we find now part B and part C? So it means that now your new function is going to be f of x is equal to our B we have already obtained as 5x squared minus 2. So can we find out what do we have for part B and what do we have for part C? So can we find the answers for those parts? Oh, okay, looking through the chat now. Christian is saying A is 5, B is 18, and C is -2. Okay, thank you, Christian. But Justin was saying, no, I don't know why. 18 and -2. But B is 2. 18, Davinia, Jessica, -2, Megan, 18. Patricia 18, Agatha 18, and -2. Okay, I think we're on the same page. Paul, please come sing correct answers in the chat. Daniela has got a question. Daniela, can you raise up your hand? Yes, Daniela. Unmute. Daniela?
Yes, teacher. So my
Yes.
question is, when we're dealing with quadratic equations, I recall something about factors that we didn't handle in question letter A, that question. So I'm kind of confused about that. Where do the quadratic equation ideas come in from?
Okay. Now, if for this part, okay. Now, Daniela, don't go off. If for this particular question, the task was to find out the value of x. Because this question can as well be set in the format that will require you to find the value of x. So for that one, they can tell that f of x is equal to 5x squared minus 2. And they will tell you that f of 2, they tell that f of x is equal to 18. And here they may want you to find the value of x. Now, for that particular one, where you are seeing the power as a 2 on the unknown is where you need to go on and find out using the quadratic approach. So for you to use the quadratic approach, it means that the unknown you are finding has a power of 2. That's when we can. But since here B doesn't have unknown, then it means that we cannot. But if the question had been set whereby B had a power of 2, it means that here in our solving, let me just put there a 2 here. If it had a 2, it means that we wouldn't have just gone direct like that. Would have gone further to use the quadratic key things. But since it doesn't have, then we can't. But we are going to do a question further inside that will require that kind of thing.
Thank you, sir.
Okay, yeah. Our next question, we are going to find where it's going to be used. Okay. I don't know whether it is a question from Lily and Maz. You can ask, but yeah, for this one, I want you to try for me. Here you are doing for me part E. I'm interested. Everyone, we are going to try part E is what I'm interested. And you are doing Roman 1, Roman 2, and Roman 3 is what I'm interested
Excuse me,
in.
sir.
Yes, please.
So in the like in the past activity, where it was like f in brackets x is equal to b, x to the power 2 minus 2, and then it has there's more to the question where it says and f in 2 in brackets equals 18. So now like where there's x in the unknown part, is it okay if we keep thinking of x as 2?
I did get you clear.
Okay, in the past activity, it said f x in brackets is equal to b x to the power 2 minus 2, and f in 2 in brackets equals 18. So now where there's x, where there's x has to be 2.
Yes, because this one inside the bracket is what substitutes in it. Like when you look at this function, you relate. Look at this given function and look at what you have. This x fits in the position of where 2 is.
Okay, sir. Thank you, sir.
Okay. Yes, Marion. Marian? Marian?
Excuse me, sir. Excuse me, sir.
Yes, go on.
For me, I'm confused. Sir, why is it some people they got 18? Mm?
I beg your pardon. Why did some people get 18?
For me, I'm confused there.
Where? For which part?
Part B.
Are you saying for this number I've displayed or for the previous one?
The previous one.
Oh, now, the 18, where the 18 came from, it was within the question. The question told you that when you put 2 in the function, the answer you get is 18. But there was something they were hiding from you that they wanted you to find. So 18 was given in the question.
Yes.
Hmm.
Okay, I got it.
Okay.
Okay, thank you, sir.
Okay. Okay. Let me know people are finalizing with part E. Yes, Mars?
Eh,
Okay. 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 Let me know people have finished part E. Yes. So what we are going to do, you raise up your hand and you just share with us how you have been able. Oh, okay. Let me just look through the chat. Okay. But some people have already put. Let me start with Mark, Shakul, and I think Lillian. Yeah, those people have asked. Jessica. Okay.
For the
okay.
first one,
Oh
Okay.
God, Jesus.
for the first one of f of 7, obviously I replaced the x with the 7, whereby 7 squared plus 2, that is 49 plus 2, getting 51.
Okay, thank you.
Then,
We
then
can
for
have
the
another
second one,
person.
for the second one,
Yes.
it was f into bracket -3.
Mm.
Yeah, I replaced the x with the -3. -3 squared plus 2. Yeah, -3 squared, -3 times -3, it's 9. 9 plus 2, getting f into bracket -3 as 11.
Okay, thank you. Another person. I had it. I couldn't. Okay, another one. How? Shakul, have you finished? Michelle?
May I have a question?
Okay.
I have not understood the person who explained first.
You did not. Which one? This part, eh?
The first person who explained of 7.
Hmm.
I didn't understand him.
Now, for the first part, this was this is what they wanted us to find. They told us that where there is x, they want us to put 7. And when you come here in our question, you'll have f of 7. So wherever you are seeing x is where you're going to put your 7. So it means that you'll have 7 squared plus 2. Now, 7 squared means that you're going to multiply 7 times 7. So 7 times 7 will give us a 49. So now that means that you'll have 49 plus 2, and then you'll end up with your 51.
Okay, I had made a mistake.
Oh, okay. Okay. I
Sam,
want us. Yes.
I'm doing Roman numeral 3.
Okay.
Yeah. It
Yes.
is f of a half
Mm.
is equal to a half squared plus 2.
Okay.
The square root of a half is not the square root, it is the square of a half is 0.2 plus 2.
Okay.
Which the answer is 2.25.
Okay. 2.25. Okay, good.
5.
Yeah. So this is one way. Thank you. Another person could as well. Now you need to know that a half squared is the same as a half times a half. And when you are multiplying fractions, multiply the numerators separately and then the denominators separately. So 1 times 1 will give us a 1. Out of 2 times 2 will give us a 4. Then it means that you'll have a quarter plus the 2, which is the same as 2 quarters. So another person would write the answer as 2 quarters or 2.25. Okay, let me hope now we're on the same page. But maybe one more thing, maybe for the last part where they told you that f of a. Now here they left you unknown. So there, it means that your answer, do not struggle to create things that do not exist. So your answer will just remain a squared plus 2. So it remains there like that with an unknown. So you don't force things, you don't put this and the other, but you just leave it like that and it will give you that. Let me hope we are on the same page. Okay. Oh, sorry. I don't know why I ended the sharing. Okay. And now we are going to go to another type. Now, like you know very well, when we are dealing with the math is like a language that we can use also in other subjects. So we can as well use it when it comes to physics. So we have brought in some idea of physics. You studied linear motion in physics. Can everyone first try out and we see? So we are trying find the initial velocity. It has no value. Where do we get? Oh, okay. Recording in progress. Okay, let me hope everyone has tried out. Now, you are going to notice that sometimes in order for us to be able to pass some of these questions, you may need the other subject. Like I told you that this topic we are dealing with is going to involve in composite things. It involves you to even process some things you have already studied in order for you to be able to get it. Now, when you look at this question, if you don't know what we call initial velocity, you may not be able to obtain it correctly. So I need first test whether we know some physics. So who can tell us what you understand by initial velocity to help out people or to help out those who have not yet obtained the answer? Okay, I'm seeing Marion's hand up. Okay, Atwine?
Yes.
Atwine?
Yes.
Okay. Yes,
Initial
shall we?
velocity. Initial velocity means the starting velocity.
The starting velocity.
Yeah.
Okay. Very good. The starting velocity. Yes, Kiza. Do you have another answer?
Initial velocity means the starting velocity, and it means the starting velocity, and the term zero is. That's why I replace t with the zero, and zero squared is 0 minus 9, getting the -9.
Okay. 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 It is okay. When we talk about the initial velocity, it means the velocity with which the particle starts with when you start doing the timing. So for this particular one, I considered my starting velocity to be t is equal to 0, the initial velocity. Whenever the particle is starting, the time you use, like that time when you start your watch, when you start your clock, when you start the timing. But I wouldn't want you to cram or to take it like gospel that always it is 0. Sometimes they may tell that the particle started with an initial velocity of 5. It started with an initial velocity of this and the other. So please do not cram that always, whenever you see the word initial velocity, t is going to be 0. It is not true. Initial velocity means the velocity at which you start with. So sometimes you may start doing the timing when you are timing, and you start your time when someone has maybe rotated the field after some time. So that when you start doing the timing. So the initial velocity, we shall have it here as 0. Okay, so that means that we shall expect you where there is t to come and put your 0. Okay. Calvin, you have a question? Calvin, is it a question? Okay. Okay. Oh. Oh. Yes, okay, good. Okay, I have seen. Okay, now what are we going to, we are going to substitute.
Why should I?
Yes? Okay, I didn't pick your question well. So our t is going to be 0. So I'll expect to have v is equal to 0 of t squared minus 9. So we shall have v into 0 will equal to 0 squared minus 9. And we know that 0 squared is 0 minus 9, which will give us -9. And when you look at velocity, they have told us that our thing is in seconds. So this is going to be meters per second. Now, some of you may ask, why is it negative? Can velocity be negative? Yes. So when it is negative, let me just show you graphically how this kind of thing looks like. Now, when you draw it graphically, you'll find that this is just a rough thing. You'll find that it is something of this nature. But negative, or when you find that it is negative, it shows you let me say it is below the projection point. Whenever you project something below below the surface, you'll find that your velocity will be equal to negative. But this one, you'll find it further when you come into when you go into math and physics. But also, if I can relate it a bit, when you let me say this is my velocity and this is my time graph. Some of you might have made time graphs that are of this nature, something like this. They can also exist, whereby you have your velocity, but you find that your velocity here is a bit of negative. Or when it is below, okay, the better one can look like this. Let me draw something better. When you may find something of this nature, something like that, you'll find that this is your velocity, but when you look at your velocity, this is the time, your velocity is maybe down here. So it is very possible. So you can have something of this thing, this nature. So that is how it can appear graphically. But time cannot be negative, but velocity can be below the projection point. Okay, allow me to continue unless someone has a question. So our next question for this number wanted us to find the velocity after 4 seconds. Can we try out that? The velocity after 4 seconds as I answer this question. Yes, is it V4, Vivo? Yes.
So I'm lost.
Where are you lost from? From which point? Hello? Oh, okay. I didn't get you. Now here, your reasoning would be is that initially, time can never be a negative. Time will never be a negative. So the starting point for time is always going to be 0. So your initial velocity is going to be 0. That is what you need now to know. If it is in time, in terms of time, time can never be a negative. So the lowest time we can have is 0. So that's why we say that initial velocity will happen when our time t is equal to 0. That's what I'm saying. But I don't want you to confuse that initial velocity is equal to 0. But what I want you to know is that the time is equal to 0 initially when you start timing. So here, t is the one that is 0, but not velocity. So people, I don't want you to cram that initial velocity must always be 0, 0, 0. No. But time is equal to 0 initially. Whenever you are starting to time, that's when t is equal to 0. Okay. So we are doing part B. Yes, Desire? Okay. People have got the answer. Yes. Yes, go on.
Like I find the velocity after 4 seconds. So I said V into T is square root. So I substituted in the 4, which is V is equal to, like V is equal to 4 in brackets, is equal to 4 squared minus 9.
Okay.
So I got 16 minus 9. Which gave me 7 meters.
Which gave you?
7 meters per second.
Okay, 7 meters per second. Okay, thank you. Yes, and when you draw this on the graph, this is where you'll get it will be a curve. Whenever you see a squared will tell you that that is a curve. So roughly, you have something like this, whereby this is your -9. Here you have, this is your velocity. I'm just using roughly. So you'll have something, this is our time. Let me just say 4. So you'll have something like that, something like that. Yeah, but it will be in a curve form. Okay. Then the last one, find out part C. Find out for part C. It is the last one. It is oh no, we have part D, find part C, and then we got part D that I want you to, where we are going to bring in the idea of quadratics. I'm seeing a hand up. Yes, Lily.
I wanted to work out that part C.
Okay.
So I would say V of, now that it's after 10 seconds, so we shall say V of 10.
Okay.
V of 10 is equals to, I'll replace the T and I will say 10 squared minus 9.
Okay.
So it's V of 10 is equals to 100, since 10 squared is equals to 100 minus 9.
So what do you end up with?
So I'll end up with V of 10 is equals to 91.
Is equal to 91.
91.
Okay. 91. And please, let's not always forget the units in case it is in velocities. Okay. Thank you. Now, that is the last one. Now, part D will require us to think. That last part will require us to think. They are asking you that, at what time does the particle come to rest? May I know through the chat, at what time does the particle come to rest? Can we have some discussion? What do you think? What happens when a particle comes to rest? Oh, I've already put for you the answer. Unfortunately, I've put for you the answer. Yeah. Okay. I've put for you the answer. Yes, but Desire, you can tell us.
Okay, when the particle comes to rest, that marks its final velocity and time. Its final velocity will be 0. No?
Okay.
I'm
The
lost.
final velocity will equal to 0. And I want us to take that one important, that when you are coming to rest, just assume maybe you have been driving and someone has stopped you. It means that if someone stops you, your velocity is going to reduce up to when it reaches 0. So when velocity v is equal to 0, it means that you are not moving, but time is moving. But for you are not moving. Those who have been on the road, whenever the policeman stops you, it means that you are coming to rest, such that you can be able to meet that person. So once you come to rest, that I'm meeting the person, it means that your final velocity v is going to be 0. But since you have been going somewhere, the time will still continue to move on. So here, what does it mean? It means that this v is equal to 0. So I expect you now to have t is equal to t minus 9. So where there is v is where you're going to put 0. So it will say 0 is equal to t squared minus 9. And now here is where you're going to solve your equation. But I want you to first try it out. And then we see what we are getting. So Diane is saying it's getting 3. So we are finding what is that time. At what time do you come to rest? Becky is saying 3. Spark is saying 3. Atwine is saying -3. Okay. Okay, I think people are getting 3. Others are getting -3. Okay. Yes. Now, here now is where we need always to reason. Here, I expect you to take the -9. But this is a quadratic equation, so I expect to say 0. Okay, I can say 0 plus 9 is equal to t squared. So 9 will equal to t squared. Then take the square root. So your time here will equal to 3. But now, since they have asked for the time, please take note that our time we can never have time as the negative. So that's why that for people who are considering -3, you'll be marked wrong. Why? Time cannot be a negative. So here we shall have time is equal to 3 seconds. So here you only consider that positive part because time cannot be a negative. But for some other, for other numbers you may find when it is not specifically time, then please go on and give those two answers. But also you need to be very careful. Sometimes you may go on whereby, let me say, your velocity maybe was given as t squared minus 9t plus 4, something like this. When you equate this to 0, you do not start 0 equal to t squared minus 9t plus 4. Please here, don't just go direct here. The moment, remember our quadratic equation, ax squared plus bx plus c is equal to 0. The moment the coefficient of b is not equal to 0, it means that you can't just go directly like this. So it means that here, use any approach you are sure of. Whether you are very sure of the graphical, whether the bulldozer method is very easy for you, whether the completing squares is okay for you, always use that approach. Whether factoring is easy, you use that approach. Whenever you find that the coefficient of x is not equal to 0, please do not just go directly and you get a square root. Here, follow the approach of obtaining the factors and then you solve out. Okay, let me hope we are together. Kindly let me know through the chat whether we are together and we move on. Yeah. Seems people we are on the same page. Yes. Okay, looking through the chat, we are on the same page. Okay, I think we are good to continue. Okay, I have another one here. Do for me part A, and then we do part B together. Do for me part A, then part B, we do it together. Okay, I'm looking through the chat. -1 out of 9. 19 out of 3. -1 out of 9. Okay, okay. I'm seeing different answers coming in. 1 out of progress. Okay, looking through the chat, I feel we have the correct answer. Okay.
So is it fine right now?
The chat, all our answers are correct. So let me ask Muganile. Muganile, unmute. Oh, Muganile is failing. Trevor?
Yeah.
Okay, Muganile, go on.
Good afternoon, teacher.
Yes, good afternoon.
Good afternoon, teacher.
Yes, good afternoon, good afternoon.
Teacher, people are getting negative 1 out of 9, yet I'm getting an answer similar to it.
Okay, take us through how you are getting your answer.
They said if h into brackets x equals to 1 over x minus 6, find h into brackets negative 3. Then I said, in case, I found my mistake, but let me continue. H into brackets negative 3 equals 1 out of negative 3 minus 6. Yes, which will give you negative 1 out of 9. Sorry. I found my mistake. Thank you.
Okay. Yes. Now, some of you are writing your answer like that. Yeah, but this one doesn't look mathematically beautiful. Yeah, the beauty is really missing. So you must make it a bit more mathematically attracting. So having the negative up makes it much, much better. So here, better to write negative 1 out of 9. Now, for part B, is there a value where h of x does not exist? Explain. Now, mathematically, for something not to exist is something that will appear unfair. You look at it when it is not really fair to you. So in mathematics, something not to exist, I want you to put in your calculator. When you say 3 divided by 0, which answer do you get when you place your calculator? 3 out of 0. Someone is saying, error. So you'll find that you are getting a math error. So Mega is getting 0. 3 out of 0. Yes. So anything, this one is like, okay, it is a math error. In other words, you find yourself here you find yourself, you have the money. Here, like mathematically, it means, let me say, you have like 20,000, but you don't have people to give it to. There is no money. It is 0, doesn't exist. It means that you can't share when you don't have the people to share with. So it is nothing. So it is undefined. It is impossible. So for something not to exist mathematically, it means that the denominator is 0. Whenever the denominator is 0, it means that function is undefined. So they can use the word does not exist. They can use the word undefined. They can as well use the word meaningless. So when you find any of those words being used, it means that always your denominator will always equal to 0. In simple terms, ask your value. Which value of x, which when I place here where there is x, I will get my answer as 0. That's what the question is asking. You ask yourself, which value of x, which when I put where x is, I'll get my answer as 0. And people have already said the answer is 6. Yeah, so that is the meaning. So, however, we don't just mention, because we can use the i's to sit directly, but you may need to calculate it. So what you do, always you get the whole of your function you have in the denominator, you equate to 0. So I will say x minus 6 will equal to 0. So you find out the value of x. So you say x minus 6 plus 6 will equal to 0 plus 6. So x will equal to 6. And then your explanation, you say that for something that is meaningless, it means that my denominator is equal to 0. Let me give you another one, a quick one. I have, you don't, okay, you can calculate it in your book. I have this, x squared minus 4. And I'm asking, which value of x will make this function meaningless? Which values, in fact, here now, allow me to use which values of x will make our function meaningless. Oh, Said is saying 2, Elvis is saying 2. Davinia is saying 6. Are you sure, Davinia? 2. But my question was, which values of x will make our function meaningless? So please quote me well. Which values? And I'm only seeing one value coming in the chat. Yes, Patricia.
So I have -2 and +2.
Perfect. But can you take us through how you have obtained those ones?
Okay. So x squared minus 4 is equal to 0. Then we are removing the 4 from where it is. So x squared minus 4 plus 4 is equal to 0 plus 4. X squared is equals to 4. So we get the square root. X is equal to, so 4 under square root, we get two values. That's a +2 and a -2.
Good. Yes.
Thank you.
So those are the values that I expected you to obtain. So when you come here and say 2 squared minus 4, you'll get a 0. But still, when you say -2 squared minus 4, still you end up with a 0, because -2 squared gives you a 4. Yeah, so that's why I was intentional to ask you the values. Thank you, Patricia. Yes, Amara.
Yes, good afternoon, teacher.
Yes, good afternoon.
Teacher, I'm a bit confused with this second part of the question. So they are saying that is there a value where it does not exist? So when they're meaning, like, let me say, they have given us that example. Are they trying to tell us to prove whether X has a part of itself that may not be calculated or
Exactly. Exactly.
Yes.
That.
Can you elaborate a bit more? It's still confusing.
Like the way you have mentioned is that they're asking, is there any value of x which when you substitute in that function, the function doesn't make sense, you cannot obtain an answer? That is the question.
Yes,
Because
so now for the example is now in this question we had gotten -3. -3 minus 6, we got 1 out of -9. These are still a fraction. So that means in the case of like dividing it, you'd get decimal points, a negative decimal point. So
now that means it is okay.
It is
It
okay.
makes sense. Yeah. But when you substitute 6 there, you notice that you are going to have your function as h of x is equal to 1 out of 6 minus 6, which will give you 1 out of 0. So whenever you see 1 out of 0, this one cannot exist.
Oh, so but okay, totally canceling itself out. Okay.
In fact, it can't cancel even. It does not, it cannot.
Basically,
Like
it cannot be calculated or anything. It cannot be
yes.
worked out. Okay.
Yes. Yes. Yet for other values, you can get the answer.
Oh, okay, teacher. Thank you so much.
Okay. Yeah. And here for this particular one, I saw a question in the chat. As yes, Sparta. Sparta. Oh, okay. I don't know Sparta. Frank?
I've not understood.
Okay, you have understood. Okay, Frank? Okay, I'm fading Infinix or Frank or Patricia as the rest we are trying out.
I was just asking, I was requesting you to elaborate more on the explanation you've given for that 1 out of x squared minus 4 equals to 0.
Okay, Patricia, which part is still disturbing you? The rest we are trying part A.
Like this thing you've been explaining all the value where h of x doesn't exist. I've not understood it very well.
Okay, now for something not to exist, it means that Patricia, you cannot find an answer to it. That is what I'm saying. So when you look at Patricia, I want you to try out for me this and tell me which answer you get. Find for me f(x) of 2 and tell me which answer you get. Sorry. Patricia, find f of 2.
I get 1 out of 0.
Now, 1 out of 0, does it make sense? Can you, just imagine you have a cake at home, but you have no one. Can you say that I shared the cake?
No.
Yeah. So this is what we say that does not make sense. Whenever you find that down here, the number you are getting is a 0, it means that that number cannot work on that particular function. So that number should always be excluded out of the integers.
Yes,
So
thank you.
that's what now they're asking. That is there any number, which when you, any digit or number, which when you put there doesn't exist?
Okay.
Okay. Infinix, you had a question?
I have x is equals to 7.
Sure, for part A?
Yes.
Okay, can you take us through how you reached there?
I said h into x is equals to, no.
Which part?
G into 3 is equals to 4x minus 5. Then where there was x, I put there a 3. Multiplying 3 minus 5.
Okay, don't remove,
Minus.
don't go off.
Okay.
I want you, were you around when we are starting this lesson?
No, I just joined.
Oh, do you know what you call an input and what you call an output?
No.
Oh, now I see where the problem is, because what you are doing is a bit different. Now, there is a difference. This is number 1 and number 2. Now, for number 1, it means that your output is 3, but they have not given you the input. Whereas for number 2 here, it means that they have given you the input. So the approach for those two parts is totally different.
Okay.
So this one, number 1, is not the same as number 2. For number 2, what you have done is correct. Are you getting it? If they had given us G of 3, that was okay. You were going to just say 4 times 3 minus 5. So your answer was going to be okay. But here now they have told us that our output, what we get when we put something inside, is 3. So here the question is, which value, which when you put here where there is x, your answer is 3. Are you getting the difference?
Okay. Yes.
Yes, here it is saying which value of x, which one you put here, you get answer 3. But for you, what you have done, here what you have done is that when you put 3, you get this answer, which is now total. You have set your own question. Hope we are together on that.
I've got my answer too.
Now, how have you gotten to take us through now?
I've said 0 is equals to 4x minus 5.
Okay.
Then I brought the 5 where is 3 and added and I got 8. Then I divided both sides by 4.
Okay. Now that
Like
is very
that.
correct. So divide by 4, and x is equal to 2. Okay, thank you. That is correct.
Okay.
Okay. I have, okay. Yes, Chiza Apollo.
I'm going to be taking you through part B.
Okay.
When h of x equals to 15, and now h of x equals to 7 minus 2x. So where there is this h of x, I replaced it with negative 15, and I equal to 7 minus 2x. Yes, negative 15 equals to 7 minus 2x. I collected like terms. This positive 7 came here and become a negative, making it negative 15 minus 7 equals to negative 2. I divided both sides by negative 2, equaling to x as
before. What was negative 15 minus 7?
It was 22, negative 22.
Okay.
And then I divided both sides by negative 2. The answer is 11.
11.
Yes.
Is it okay if you say 9 is mapped to 3?
Okay. Yeah, thank you. Yes, Virginia, that is correct. Yes, Virginia.
Teacher, could you please explain B again? Because like I did it in another way, and since you're saying this,
You good?
Answer must be wrong.
Okay, can you tell us what you did, Virginia?
I got, okay, it says x is equal to negative 15. I made x negative 15. And then I got my answers 37.
Oh, now, Virginia, you have done 2 things. Now, Virginia, you stay on, Virginia, when I have h of x is equal to negative 15, what is your input and what is your output? Are you getting the question? Not yet. Has Virginia gone? Virginia, can you unmute?
Yes, sir.
Yes, I was asking. When I have h of x is equal to negative 15, can you distinguish the input and the output?
The output, okay, the input is negative 15, right?
Okay, let us go back to sugarcane and sugar. Which one is the output? Which one is the input?
Sugar is the output, sugarcane is the input.
Now, this is the input. Now, for this particular question, the output is the negative 15. This is the sugar. But the input is what you don't know. So they're asking you, what did they put to get that sugar? Are you getting? But now for you, what you have done is that for you have substituted the sugar they have already obtained. So there is a very big difference, Virginia, with having h of negative 15 and h of x is equal to negative 15. So this one means that your input they have given you the sugar canes and they want they're asking you how much sugar can they give you?
Yes, teacher.
Okay. Can you now, I don't know whether you have got the difference.
I've understood the difference.
Okay. So what are you going to do now? Share with me.
So now that I know that h into bracket x is actually the input and negative 15 is what we've got. So in this case, when they say find x when hx is equal to negative 15, and they're giving us g into bracket, they're giving us 7 minus 2x. Since 7 minus 2x is the output and negative 15 is also the output, we're going to equate them in order to get the value of x.
Perfect.
So we'll say, so we'll say negative 15 is equal to 7 minus 2x. We'll collect like terms. So negative 15 minus 7 is equal to negative 2x. Then we'll get negative 22 is equal to negative 2x. Divide both by negative 2 and obtain 11 as the value of x.
Okay. Okay. Thank you. That is very okay. 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 Thank you. I'm seeing a hand up. Who has not said anything? Deborah, Desire, and Frank.
Okay. I was wanting to take you through in part C.
Oh, okay. It is well.
Yes.
Okay, take us through.
Yes. They are saying g into x is equal to h into x. So I got 4x minus 5 is equal to 7 minus 2x, which gave me 4x, whereby I had to collect like terms. And the negative had cross, whereby it became a positive. And that, it became a positive, and that was 4x plus 2x, giving me whereby the 5, which was a negative, it crossed the equal sign and it also became positive. It gave me 7 plus 5. I got 6 and I divided both sides by 2, whereby I got my value as 2.
Yeah, perfect. Perfect. Fantastic. This is very good. Thank you. Okay. Let me hope. I don't know whether Frank is a question. Frank and Infinix Galaxy, is it a question?
Must.
Yes.
I'm not understanding.
You're not understanding?
Yes.
Mm.
Pardon. I'm requesting the pardon.
Which part? Which part?
On the previous questions.
Is it possible to be specific? Which question? Part A, part B?
Part B.
Part B. Now, we are saying that for part B, we have h of x is equal to 7 minus 2x. And they have given that h of x is equal to negative 15. When you look at h of x, here the question wanted us to find the value of x. They are telling you that in this is the function, that for this particular function, the moment you put in the value of x, the answer you're getting is negative 15. But which value of x is that one? That which when you substitute inside, you get negative 15. That is what the question is asking. That which value, which when I put here where there is x, I get my answer as negative 15. So here they want you to find the input. So for some cases, you'll be finding the input. For other cases, you'll be finding the output. So that's where now you need to understand that here, h of x of negative 15, it is totally different from h of negative 15. H of negative 15, here they have given you the input, and now they want you to get the output. Whereas for this particular one, they have given you the output, they want you to get the input. So what you have to do, since they have told you that h of x is negative 15, you will just come here where there is h of x, and you put negative 15. So you say negative 15 will equal to 7 minus 2x. Then the moment you reach here, collect your like terms. The unknowns be on their own side, the knowns be on their own side. So here, 7, I will take it this side. But since 7 is positive, the moment it crosses, it becomes a negative. So I'll have negative 15 minus 7 will equal to 7 minus 7 minus 2x. Negative 15 minus 7, they told us was negative 22, will equal to negative 2x. So you divide by negative 2, divide by negative 2. Negative and negative, they will cancel to give you a positive. Then by 2, 1, by 2, 11. So you end up with your x as 11. I don't know whether we are okay.
Yes, sir. Thank you, sir.
Okay. Okay. I think I want to just answer now questions. Oh, yeah. Okay. I want to just answer questions, and then Dara and Olive be the last people. Dara and Olive.
Okay, sir. Thank you.
You're welcome.
From what I'm asking, this part C, I did it, but I did it in another way, not the same way like this one.
Okay.
And I got the correct answer. So I don't know if I can use those two methods. And I get
which method did you use? Kindly share with me.
When I was correcting like terms, okay, I said that g of x equals to h of x. Then I said that it is the same as 4x minus 5 equals to 7 minus 2x.
Okay.
Then I corrected like terms like this. I said negative 5 minus 7 equals to negative 2x minus 4x.
Okay.
Then negative 5 minus 7, I got negative 12 equals to negative 6x. Then I had to divide both sides by negative 6. And I got my answers to x as x equals to 2.
Yes, Mugisa, you are very correct. Very, very correct.
Okay.
Okay. Dara? Okay. I'm failing to get Dara. Yes, Dara? Okay. I'll fail to get there. Okay.
Okay, teacher.
Yes?
Right. My question was like, if at all you're having a function, let's take an example. F into x is equal to 2x plus 1. But then the function is rather like kind of changed, whereby the function f will have a power of a negative 1. How can you come across that equation?
Okay. Let me say you're saying you have a function and something like this. Let me hope I've picked you well. There. Something like that. Okay. What I heard from his submission, he was saying that what if it is a negative? Now, if you have f of x is equal to 2x power of negative 1, and when they have given you this, whenever you meet in mathematics, whenever you have a to power a negative number, from your indices, kindly remember this is the same as 1 out of a power b. So similarly, here you do the same. This is the same as 2 times 1 out of x power 1. which is the same as 2 out of x. In case this was 2, maybe it was 2x power negative 2. Still, this is the same as 2 times 1 out of x power 2, which is the same as 2 out of x2. But if you were referring to this f power negative 1 of x, then here we have not reached this point. This is what we call inverse. Yeah. So if this is what we are referring to, this one we call it inverse, and we shall handle it in our next lessons. We have not yet reached there. Okay. I think, okay. So allow me that we shall end here for today. Those who have just joined us, thank you for joining. I've already given you some work to do. Those who have just joined, kindly you can just join the WhatsApp group. We have a WhatsApp group where we communicate, and always we start our lesson. Those who have not yet covered circle properties in senior 3, we start that lesson always at 5 a.m. And today we are able to look at our first property of circle properties of circle theorem. And we are going to continue tomorrow, the same time, still at 5 a.m. And we shall be ending at around 6:45 if nothing happens, but not going beyond 7 to allow you to do some housework, but also to start your day a bit more productive, because you know very well that during the day, home is always very destructive. You can barely do something at home, more so in those during the day, there will raise a lot of distraction. That's why we always use those morning hours when the brain is still very fresh to do something constructive, such that in that day, even if you get distracted, but when you know you did something constructive. So always those lessons will start at 5 a.m. daily. And when we reach, let me even just warn you, when it comes to third term, that holiday of second term, then we shall even we can start at 4, because there we shall be doing revision of mocks and the rest of that. So our next lesson will be there tomorrow. Tomorrow you'll have another subject, but still we shall have math at 5 a.m. up to 6:45. I've shared the WhatsApp group link for those who are not yet on any WhatsApp group. That is the WhatsApp group link I've shared, and then we shall keep updating you. Thank you so much for attending. Those who came in a bit late, we shall share this recording shortly on the YouTube channel. Thank you so much for attending. Let me wish you a good evening. Those who have finished the work, we are going to open the WhatsApp group and you can share the answers you got for the exercise. Thank you and have a good day, everyone.